Okay, in the last video, we used the integration by parts technique to solve this integral here, and this was the answer that we derived, which is sort of complicated. So we want to take a little bit of time here and see if we can prove that, in fact, we should have the correct answer. And we would do that by taking the differential of this side of the equation, and that should be equal to then the secant cubed of theta d theta. So let's try that out. Here we have the differential. This is going to be 0, of course. And let's see what we have. This would equal 1/2 the secant of theta times the derivative of this, which is a secant squared of theta. So right off the bat, we have a secant cubed theta d theta term multiplied by 1/2 plus 1/2 this times the derivative of this, which we just did. So now we have this times the derivative of this. And this is the secant of theta times the tangent of theta. So we have the tangent squared theta, secant theta d theta. And let's see, now we have to do some logarithmic differentiation. So we have plus, this is in the denominator, secant theta plus the tangent of theta. And we have 2 here, so let's put the 2 in. And then we have to take the derivative of this. And this is going to be secant theta tangent theta d theta plus secant squared theta d theta. So we have this divided by this. We could factor out a secant of theta out of this. Will it do us any good? See, this stuff here will stay the same, so let's just work with this for the moment. Here we have 2 secant theta plus the tangent of theta. And up here we can factor out a secant theta d theta. And this will be multiplied by the tangent of theta plus a secant of theta. Okay, and these go away. So we have now, we have this plus 1/2 the secant of theta d theta. So let's rewrite this. All of this stuff here is a secant of theta divided by 2. So we have this plus 1/2 the secant of theta. And let's see, from these 2 terms here, we can factor out a secant of theta. So we have 1/2 secant cubed theta d theta plus 1/2, and this is a d theta part here that we forgot to write in, the secant of theta d theta times tangent squared theta plus 1. And that is the secant squared of theta. So it looks like we're going to have this 1/2 secant cubed theta d theta plus 1/2 secant cube theta d theta. Add them together, of course, and we'll get this. So, yes, we did prove this is the correct answer here. Now, notice that here we use integration by parts. Something you might want to try on your own then. Suppose we just had a more general problem, and we said, take the integral, the secant of theta to the n power d theta. Use your integration by parts as we did here, and see if you can derive for yourself a more general formula here when the secant of theta is raised to a power. And again, you shouldn't have any problems. Just go ahead, use the same technique as we started out, and take it step by step and see what you come up with. Okay, that's it for now. Come back and join us for some more videos, and we'll try and solve some more problems.